Hey, also we're going to continue with 2.1 on functions, and first thing we're going to talk about is like when to like restrict our domain, and like we're going to talk about the domain today. So in this first one, we have express the area of a circle as a function of its radius and then find the domain. So the area of a circle is A equals pi r squared. And then to write it as a function, we usually have like f of x equals, but we're just going to use a. So a of x equals pi r squared. And now we're going to find its domain. So if we think about this, the domain is our r value. So what can r not equal? So we have to think in context for this one. So if we're talking about a circle, we know that radius of a circle cannot be 0 because then you wouldn't have a 0. And then we also know that it couldn't have a negative radius because then you just can't make a circle out of that either. So our radius or our domain has to be greater than 0 to then make a circle. So our domain is r such that r is greater than 0. Alright, so here is just some properties about adding, subtracting, dividing, and multiplying functions. And so we're going to start with finding the domain when we add two functions together. So when you add two functions together, your domain restriction is just both of the original equations' domains. So for f of x, so the domain of f, and remember in our fractions, it's when our denominator equals 0. So in f, that's when it equals -2. So x such that x cannot equal 2, -2. And then for g, our domain would be that x couldn't equal 1. And when you add them, then the domain is just both of those restrictions. So the domain of f plus g of x, d of f plus g of x, is x such that x cannot equal -2 or 1. And then this same thing goes when you are subtracting your functions. It's just the domains of the original. So we already said what d is, and we already said what g was. So the domain of f minus g of x is x such that x cannot equal -2 or 1. Sorry, it's Sunday morning and just still waking up, y'all. Alright, so when we are multiplying our functions, the domain is also both, and so we can just again write d of f times g of x is x such that x cannot equal -2 or 1. And this property is stated right here. So for adding, subtracting, and multiplying, the domain is the combination or the union of both domains. So everything listed. And then for dividing, it's the domain of f and g. So first we find f, so whatever's in the numerator, it can't equal the f domain, and it can't equal the g domain, but then it can't equal once you actually are like solving. So let's just go through. So we know so far that x such that x cannot equal -2 or 1. And now we're going to keep solving here. So we're going to actually divide these. So 1 over x plus 2 divided by x over x minus 1 we're going to multiply by the reciprocal. And that gives us x minus 1 over x times x plus 2. And this denominator here cannot equal 0. So after you're actually dividing them, that denominator also cannot equal 0. So x cannot equal 0, and also x plus 2 cannot equal 0. And that's where we would end up getting x cannot equal negative 2, and then this one's already solved, so x cannot equal 0 is also added to our list. All right, let me know if you have any questions. That's it.